Welcome students, today we'll be going over Systems of Equations by SMS Tutoring. As far as systems of equations, we're going to be going over linear systems, meaning systems that when you were to graph it, it would create a linear line, a line. There are three ways you can solve a systems of equations. There's substitution, elimination, and graphing. For today's video, we are going to be going over substitution right here. Now, here's an example that we are going to start off with. The goal when it comes to systems of equations is to isolate for a variable when you're using substitution. So that is exactly what we'll be doing. If you do not know how to isolate for a variable, please watch a following video and come back to this one. When it comes to isolating for a variable, you can pick whichever equation that you'd like. So if you want to pick this one, you are more than welcome to do that. If you'd like to pick this one, you're also more than welcome to do that. But some key factors that you would want to consider when picking which variable you want to isolate for is always try to isolate for the one that is closest to already being singled out. If you look at the first equation right up here, you notice that you have a 2x and a y. If you were to isolate for x using this first variable, you would need to do multiple steps to get here because x is being multiplied by 2 and added by y. Whereas if you wanted to just isolate for y, all you would do is subtract 2x. Now, it doesn't matter this step. It doesn't make it, if you do either or, you're not going to get the answer wrong from it unless you do the process wrong. But if you'd like to pick a faster, more efficient, or easier variable, those are things that you'd want to consider. If you go ahead and look at the second equation, you notice that both x and y are somewhat by themselves, meaning there's no coefficient in front of it where you need to divide by anything. So they're almost isolated. If you want to get the x by itself, you would just move the y. If you want to get the y by itself, you would just move the x. But notice how there's a subtraction in front of the y. You also would need to multiply or divide by -1 so you can get y by itself. Personally, if I were to pick the first equation, I'd want to isolate for y. And if I were to pick the second equation, I would want to isolate for x. I'll do both of them on the side so you guys can get an idea for how to do it. So starting off with 2x plus y. If I were to isolate for y, I would just do minus 2x to both sides. And I end up getting y equals 7 minus 2x. Now if I were to take x minus y equals 1, and if I were to isolate for x, I would have to do plus y to both sides. And I get x equals 1 plus y. Both of these work. So you can pick whichever one you'd like from here. I'm going to pick this one right here. There's no specific reason as to why I picked it. I just wanted to pick that one, so I'm going to use that one. Because I picked the equation that I isolated x for right here, we are going to substitute x for 1 plus y, meaning with my other equation, 2x plus y equals 7, I'm going to take that x, and instead of writing x, we're going to write 1 plus y. So we're going to do 2 times 1 plus y equals x. I really want you guys to understand that all I am doing with this x value is substituting 1 plus y because that's what I found here. If you guys found for y 7 minus 2x, you'd plug that in for y as well instead of for x. So whatever variable you ended up isolating for, that's the one that you are going to be substituting. And the reason behind us wanting to substitute it is so now we have one variable and we can isolate and solve for that one variable to find a number. Before, if you guys go ahead and look at our equations right here, we had two unknown variables in our equations. And you cannot solve an unknown variable as far as getting a number value for it. For example, you wouldn't have been able to get x equals a number or y equals a number just by simply trying to solve these and isolating for the variable. But when you use the substitution method, you're able to solve and get one variable and then isolate for that one variable to get a number out of it. So for this one, our only variable left is y. We can solve for y now. We're going to go ahead and distribute the 2. So we're going to get 2 plus 2y plus y equals 7. Now we're going to do minus 2 to both sides. And then we're going to get 3y, because I added those, equals 5. Now we're going to isolate for y. And we end up getting y equals 5 over 3. This is a numeric value that we can work with for y. Now the next step is that we're going to find our numeric value for x. When it comes to finding our numeric value for x, we can go ahead and use the equation where we solved for x. X equals 1 plus y. Now instead of having y, we know what y is, so we can plug in y. Plus 5 over 3. Now we're going to isolate and solve for x. Notice how we have a whole number plus a fraction. In order to be able to combine a whole number and a fraction, you need to have a common denominator. So I'm going to go ahead and rewrite 1 as 3 over 3. We end up getting 8 over 3. So what was all this for? We found what x is and we found what y is. What this would mean is if we were to plug in x and y into both of these equations, these two conditions would satisfy it. The goal is to find an x and a y value that not only matches this equation, but also this one. Let's go ahead and check our work. Check your work. If we have 2x plus y equals 7, we're going to write 2 times our x value is 8 over 3 plus y, which is 5 over 3, equals 7. When it comes to multiplying a whole number by a fraction, we're going to make that whole number over 1. And now we're going to multiply the numerators together. So 16 over 3, and then the denominators together, plus 5 over 3. Let's see if that equals 7. If you have any questions on multiplying fractions, adding fractions, subtracting fractions, dividing fractions, please let me know in the comments and I'll make a separate video on that. When it comes to adding the fractions, since they already have a common denominator, we're going to make it over 3. And we're going to do 16 plus 5. 16 plus 5 is going to get us 21. And does 21 over 3 equal 7? It does, because 21 divided by 3 gets you 7. And fractions are another way of writing division. So it works for this equation. So let's go ahead and check if these solutions also work for the next one. Now let's go ahead and plug in our x and y value. So 8 over 3 minus 5 over 3 equals 1. Since they already have a common denominator, we can go ahead and subtract them. So 8 minus 3 is going to get us, or 8 minus 5 is going to get us 3. So we're going to have 3 over 3 equals 1. Now let's see if that's actually true. Same ideology as before. Since we have a fraction 3 over 3, fractions, another way to write it is through division. So we're going to have 3 divided by 3. And does that get us 1? It does. So it seems like this solution also works for this equation. Therefore, using substitution, the solution for these two equations are going to be 8 over 3 and 5 over 3. Our next example is going to be x plus y equals 10. and 2x minus 3y equals negative 4. The first step we know is to isolate for a variable. So go ahead and do that. It doesn't matter what variable it is. Just as long as you properly isolate it, you should be good. Step 1, I isolated for x using the first equation. Step 2 is going to be we're going to substitute and solve for the variable. We're going to substitute into the other equation. 2 times 10 minus y minus 3y equals negative 4. Now I isolated for y. I'm going to go ahead and plug my y value in and solve for x. We have our x value right here and our y value right here. I'm going to save those values off to the side, and we're going to check them to see if they are correct. Okay, so it does seem to work for the first equation. Let's go ahead and check the second equation. Seems like it's going to also work for the second equation. So we know our solution is 26 over 5, comma 24 over 5. If you guys have any questions, please let me know in the comments below. Thank you guys for watching. Our next video is going to be using the process of elimination to solve the systems of equations. Have a great day.